Okay, so I guess we should start the session. Okay, in today's session, we will be learning about Kotlin language and how does the Kotlin language works internally and what are the different things in Kotlin. First of all, I would show you guys how you can actually run a Kotlin file in your command line or how to run this. As you can see, this Kotlin website provided to us by the Kotlin organization. We have this Kotlin command line compiler, and using this, we can install Kotlin compiler. And if you are using macOS, you can use this, or there are different versions that you can use how to install this Kotlin library. Some of them are easy, some of them are a little bit tough. You can go through this and install the Kotlin compiler, and we'll move to directly to the VS Code here, and we'll create a test.kt file. KT is for Kotlin, and the command for compiling this would be Kotlin C, then the file name, which is test.kt, and this is the same command that is provided to us on the website. Then this test jar, and then use Java. And also make sure you have Java installed on your system. And then okay, so it's giving us the error because the file is empty. Now let's start with the programming. First of all, that we need to know is that the functions are defined using this fun keyword, and the uh, main keyword is the entry point. And every Kotlin application, pure Kotlin application, starts its execution from the main function. And a few things, let's say how to print this. We use print ln, and we also have normal print, and we can use any string, let's say hello in this, and then let's try to compile this, and you can see the output. So this is a way of printing. This println ensures that there is a new line character after the print statement is executed. And let's now understand how variables are declared. We use var keyword in Kotlin for declaring any variable. And let's say var username. And in this, we can use semicolon and define the uh, data type of the variable that we are using. Let's say user. Now, this is one way of doing this. Or and since it's a var, we can change its value and reassigning is available. You can use username, and then let's say we want as a user you are using name, so we can assign this anything. And second type is val, which is immutable. And if I say val name equals to user, then I cannot reassign this. I cannot do this. This name is maybe something else. I cannot do this. It would provide me with an error. So this is one thing. And then next is type inference. Type inference is Kotlin automatically guesses what the data type should be. Let's say you are using age is equals to, let's say, 10. So we do not need to explicitly define that this is an int. If we want, we can define this using this int, but it is not necessary since it has type inference. And also a small topic of string interpolation that we also learned in the Dart language. We can combine two strings, or we can technically inject some variables into one string, or combining two strings, or maybe one data type inside a string. We can do this using dollar variable, dollar sign. It's using this. I am printing this name, and then the actual name variable can be entered here, and this would actually print out the name. Let's try this once. So, okay, I'm not provided it dollar. Now let's see. Okay, so you can see the name user is printed here. So this is string interpolation, and if you need to write an expression, we can do this. Let's say maybe this age plus 10 or something. We can do this as well, and this would be executed normally. Now some basic data types. The first data type is byte, and this has a range of 127, which is 0 to 127 actually. But I'll be telling you the higher limit or the upper limit of these variables. And then we have short, which is almost, I guess, if I remember, 32767, if I'm not wrong. And then int, obviously, we have, and int has, I guess, 2147. Then it's, I guess, 483647. And also we have long. And I don't remember the long's range. It's very large. Okay, so it has a very large range. Almost you can say 64-bit, if I remember correctly. This is 64-bit range. It has a 32-bit range, and then this is 16-bit, and then this is only 8-bit. So these are the numbers, and then for float and double, float, we have this, which is 32-bit decimal, and then we have double, which is double the precision, and it becomes 64-bit. So these are also few data types. And then for strings and characters, we have char, and this is for just a single character. Let's say if I want to store well num maybe, then I can just single store this, let's say a, and make sure that you are using single quotes for characters and double quotes for strings. And also make sure that you are using the sensitivity, case sensitivity correctly, because Kotlin is a very case sensitive language. If I am defining something as a capital, you should also be defining that as capital and not change that, or it will else give you an error. Next, we have Boolean, and this is just for storing true or false. And this is all for the data types that we have. And also we studied about the string, and we'll discuss about string later on. Now also, yes, control flow. For control flow, we have if, else if, and when. Now first if, and we provide some kind of a condition, and based on the condition, if the condition is true or false, this if will execute, and if it's false, this else block will be executed. Now, one thing to note is we can also assign the value. Let's say, I'll show you. Let's say I want a number to be returned by this if else block. And the thing is that if you are only using a single line, let's say, technically what happens is the last value of the if else of if any block, let's say this if block, the last value is automatically returned, or you can understand is like the value of the last line. let's say if I do not know to do this return or something, if I just provide 9 here and do some calculation, let's say this age plus 10. So what will happen is this 9 will be provided to this num at the end when this if block is executed. And let's say if I want to provide 10 based if else is executed, so I can just know that what block has been executed. And next we have a similar, you can say, replacement for switch case, which is when. And similar to switch case, we provide some kind of a condition here or some kind of a test case here. And based on the test cases value, we do not use cases here, we use directly the value. Let's say if condition is a number, I'm providing it one, and then we use arrow notation for the values. Let's say I need to do some kind of calculation. I can do this, let's say this age plus equals to 10 or something. And multiple, if I want to do multiple calculations, then I'll use this curly braces. And if I only require a single line, then I do not need to provide curly braces. I can just do it simply. And also, if multiple test cases have same result, we can also do this by using comma separations. And there's also this else block. This works similar to the default block in the switch cases which we normally use, and it works same. This has the same thing that I was discussing about, that the last value is normally assigned or returned. Let's say I want to store this value again, that is returned from these guys. Let's say I'm returning one from one, then maybe four is returned from here, and else is returning 10. So this is the thing, and it can automatically understand what the data type of the this number should be. And if I'm using string, let's say if I'm maybe providing a string or maybe a number, then it would be unknown, and it would be only decided during the runtime that what would be the default value or the data type of the this number should be. Now this is the control flow, and then now let's move to the loops part. Loops. We have two types of loops majorly. One is for loop and the other is while loop. First of all, the for loop, we have iterators. Auto iterators work like we do not need to provide any initializing variables. Let's say if we had C, we use I equals to 0, then semicolon, I is less than some limit, and then I plus plus. Here we do not need to provide something like that. We can if we want to. One better option, or you can say one modern option, is that we can use I and then provide a range which is I then dot 1 to 5. This uses the range from 1 to 5, and then we can do whatever we want to do. Let's say print, and then we want to print this I. So we can print this I simply. Now, also we have a few things for this range operations. We have down to, if we want to, since this range would normally be incrementing. We also have this down to. If we use down to here, let's say I'll show an example for I in 10 and then down to 1, and then I can also provide a step. So what it is actually doing, we are going from 10 to 1 backwards, and then the step of 2 is that the decrementing part, or you can understand it like this, that we are using an I starting from 10, and it will go till 0, till 1, sorry. And every time we are decrementing by step 2. So this is, we are taking step 2, and if we are doing, we can also provide step here as well for this range. And then for while, we simply provide some kind of a condition that until it becomes false, we'll print or maybe do some action that we want to. And also this condition is whatever we want to do to this condition, maybe increment it or decrement it accordingly. And this is simply the loops, how they work in this Kotlin. Next, we have, I guess we can learn about null. Null is important because Kotlin is a very safe language and it does not allow you to normally use null inside any kind of expression or anywhere, and not even with strings. So you have to explicitly define that you are using some kind of a null, and by default, all the regular variables are made such that they cannot use or they cannot hold any null value. And if you want to store any null value, let's say if I'm defining a string here and then I'm defining a string and I do this, so this is not allowed and this will give a compile time error. What we have to do is we have to provide a question mark here so that this string, this variable can become nullable, or we can store null inside this. And then how to use it inside this. So we have a few things that we can use. Let's say this string. Let's say I want to use something, some kind of operation on this. So first we have a call safe operator, which is like this, which is a question mark and a dot. And let's say if I want to access some kind of a method for the string, let's say a length. So if this string was null, so this call save would actually not give us any error and it would simply just move over it and does not crash our code. Also, we have also we can say explicit handling we can do. We can do this, and what it does is, let's say we have some kind of a function. Let's say this nullable string we have, then question mark, then dot. Let's say we are using the length of this. Let's say we want to provide val, then name, and someone provided a null name or didn't provide any name. So what we can do is we can provide some default value so that if the string was null, and we are checking this with the safe operator so that the code does not crash, and this else if operator does this, if the value is not null, then this value is assigned to the name, and if it is null or zero or blank, then this value is assigned to the this name variable. Next, we have this not null assertion, which is using this double exclamation. And what it does is it forces the unwrap and it throws an error if the string actually uh, is actually an null. So if we do something like this, then we will get actually an error and this will crash our code. So we should try to avoid this not null assertion in this. And so this is all for the null part. Next, I guess we should move to functions. For functions, we can simply understand it. Let's say we have some kind of a function, calculator, let's say cal, and we provided some kind of variables. So what we can do is we can store the result from this, and how do the functions are defined in this. So what we can do is, let's say we use fun keyword as we have seen earlier, and then cal, and then we provide, let's say a, and then the data type of this variable that we expect, and then b, and then int again. And also we can provide what the data type of the return function should return. So let's say in this case int, and then we can return simply a plus b. So this is one kind of a function that we can store, and what it will do is that it will provide this a and b as these arguments, and then return would provide the result into this s. So a and b are actually the parameters, and as you can see, this is simply the simple function that we can see. Now we also have single expression functions, which can be written like this, and we can just provide this equals to. So this works as well. And let's say if we want to return or maybe print something, we can print this as well. So what it does, it's a shorthand notation for this code. Whatever is provided, it is printing. And since it's not returning anything, we do not need to provide any return data type argument. This is simply the functions, and we'll discuss more about functions later on. Next, I guess we should do the collection part. We have array, and how do we define arrays? It's simply the notation is this, and then the data type. This is the way of defining any array. And let's say I want to store this array somewhere. I'll do this and then use this. We have a constructor, or you can say type of constructor that we can provide the values. Let's say 1, 2, 3. What it will do is this array of will take these values, these parameters, create an array, and then return that array. This is the data type. So this is how we define an array. And for accessing the array, we can simply do the indexing part as we normally know. Also, we have lists in this. For list, what we do is similar kind of thing. Let's say list. Then I define the data type, which is first of all list, since it's a collection variable, and then the data type inside this, and then I can provide this list of so that the values provided inside this arguments would be taken as values, and we can get a list. So let's say A, B, and then C. So this will provide us a list of strings that we have given inside of this, and make sure that this O is capital list of. Then one more thing that we have is these lists are not normally mutable. We do not change these things. And if we try to add something like, let's say this list dot add function we use for adding. So we cannot do this. And since these are immutable data types, this list is immutable. And what we have to do for immutable list is we have to explicitly define val mutable, and then I'll provide this mutable list. The name is mutable list, and then let's say this string data type is being stored in this mutable string, and then mutable list of, and then the same parameters that we defined here. So now we can change the this particular mutable list, and what we can do is this mutable dot add, and we can add whatever we want to add inside this mutable list. So these were the arrays or collections part, and we understood how lists work, and these are normally readable only, or you can write read only. And for mutable, we need to explicitly provide mutable list and then use mutable list of constructor for creating that list. Next, for classes, what we do is we have this, let's say I'm gonna define a class car, or I guess however you like. For class, we use the keyword class, and let's say user, and then we have to provide what type of uh, arguments it is going to take. Let's say some kind of a val, then first for the first name, and the data type for that would be a string. And let's say another val, and then last for the last name, and then again string. Now what we do is we use init, and this init block runs automatically. whenever the class object is initialized or whenever a new object from this class is created, this init would run automatically and we can provide anything. Let's say if I'm providing, let's say I'll give a print and this can print the last name and the first name and the last simply. And we can also have a few functions inside this to this and it's a greet function. And since this first and the last were the part of the class, we can use them directly. And if we want, we can, let's say, I'll just do simply greet inside this. So we can also call this greet function from an object that is created from this user class. So let's take an example of this. What we will do is we create a val and let's say call it an object. And then what we are gonna do is take this user and then provided the variables that we were expecting. The first was this first. So let's say we provide my name and the last. You can also do named arguments and unnamed. If you directly provide your name in these two chunks, then it can do this. It will explicitly define this first and then explicitly go to the last. Even if you do not remember, let's say if I don't remember that, but what was I asking? Maybe I needed the last argument first and the first argument at the last. So what I can do is I can provide a named argument that the last is explicitly I am defining the value of the last should be. So this is how we define. And if we are using this kind of thing, then what would happen is the first would automatically map to this name and the last would automatically map to this one. And if we are not doing this, and let's say if I'm providing the name like this, then what would happen is the name would get flipped and the first argument would map to the first variable that is argument that is being taken here. And the first second variable that is provided would be taken as the second parameter of this function. So this is how we make a object. So this is an object and we can call this object and then this greet function can be called using this notation. We can call this greet function that is inside this user class using the object that is created that you using that class. Now, next we can also copy if you want to. We have also a function which is dot copy if you want to use, if you want to copy one object or to the other. And I guess yes, also we should understand about lambdas and higher order functions, how they work. Lambdas are just, you can understand them like anonymous functions, which can be treated as variables even. So let me define one. Let's say if I want to multiply two variables, what I'll do is this, then A, then defining the data type, B, then defining the data type, and then simply doing this A times B. So whenever I call this multiply and I provide A and B into this, I'll get A into B or the result from this. Let's say if I want to store the variable, so we can store the result using this mul and then providing it the variables. So this is the same implementation that we did for this calculator, but we do not need to define an explicit function here. We are just using a single variable for a lambda here. And also about higher order function is just, let's say, I guess we'll discuss about higher order functions later on because We should also understand how exception handling is working. For exception handling, we have simply a try catch block and this try, then catch, and also we have finally, if I remember, yes. So for try catch blockage, let's say if I'm trying to do some kind of a maths or maybe some kind of a function call, or maybe some kind of an operation that might lead to some kind of a error. So what let's say here I am doing a division by zero. So this can lead to an error, or this will obviously lead to an error. So what can I do is I can catch this using E. You can use anything. This E is just for normal, but generally is being used. So is an arithmetic exception. So I can catch this arithmetic exception or the problem or the error and then print this inside here to this error. So this is this. And the finally block is actually whenever the execution of try or catch block is completed, the finally block executes always. So let's say if the try block executed successfully and there was no error, finally block will execute simply. And even if the error was there and we caught the error using the catch block, finally block will even then execute itself again. So finally block is just for knowing that your try catch block has completed its execution completely. This is a simple thing. So what we have discussed till now, the data types and how to use data types, what the range of the data types are: characters, booleans, float, double, byte, short, int, long. Then the control flow part, how if else it works, also how when works, and how can we take a return value from the, or we can technically store their last value inside a variable. Then how we use loops, and then how we use for loops and while loops, how in works for the range queries, and also how we are using this down to and with the step, which is similar to some kind this kind of a format in C code or CC or C++ code. Then how nullable variables are treated inside Kotlin. Then how functions are made using this fun keyword, and how we can also define these as single line functions, and how can we call them and store their results. Then how arrays and collections work, this array, then list, and also since this is a read-only list, we can also have a mutable list. We can change that during the runtime. Then we discussed about classes. So class, and then a few functions that we can use to copy the objects from one to another. And classes are defined using the class keyword. We can take the parameters, arguments, and then using them we can initialize our object. And this init function is a it's similar to a constructor, and it is called whenever our object is created from that class, like how we did here. And then we can also call the function of that class using that object that we created. Then the lambda functions, how lambda functions are defined. Uh, these are also similar to single line variables, but we do not need to use some fun keyword or maybe define the name of that variable function. We can just store this function inside a variable, and whenever we want, we can call this. Then exception handling with try, catch, and finally block. If we are doing something that might lead to an error, we do that inside try block. And if there's no error, the try block succeeds and the finally block also completes its execution. If there's an error, then we move to the catch block, where if we have uh, catch the error or we have actually checked what the error is, we can catch it and then print whatever the error is, and then also the finally block executes its execution. Now, I guess a few more things that are related to Android are data classes that we usually define. This would be, we'll see this actually in action in the next session where we'll be building an auth app where we'll be storing the data that if the user is currently logged in or not, or what the username is. So this is similar to that. So this is how we define a data class, and these are extremely common when we'll do the Android development. So let's say a name, and then the data type, let's say I'm providing, and then let's say the ID. So this is how the data classes are defined. And a few more things that I'm trying to remember are we have few things like companion objects in which we can technically attach um, some methods or variables that we want to an instance to actual an instance of a class. But I guess they would be much more complicated. And we also have interfaces and inheritance part, but I don't think so that that would be too complicated. But I guess we can do maybe interface. So interfaces are similar to classes. And let's say I make some car interface and I'll define a function here. Interfaces are also similarly used inside Android development. Let's say drive is a function, and car, and then I can maybe do some kind of a vehicle, maybe let's say open class, and trying to provide an example, say type, and it will be a string. Then let's say bus, maybe, and this bus would actually be this bus class would inherit from the vehicle, or you can technically say this, yes, this vehicle class, and which would be implementing this car interface. So this how this look is vehicle, and then let's say the type would be big, and then you can also provide this car, and then override the drive function, this fun drive, and then you can print whatever we want to. So this is an interface. Interface is just like if you have studied interfaces in Java, we define the functions, just the functions there, and they are abstract functions, and they do not have any implementation inside them. And the classes which actually implement, and so we inherit from another class. Let's say if I had a class this vehicle, so this bus class is inheriting from the vehicle class, but it is implementing this car interface. So we implement the interfaces, and we inherit from the classes. So what interfaces define, they are some kind of a contract, you can say. And what that contract is that there will be a few functions or maybe a few variables, So they all are abstract. And what the meaning of abstract is that whenever you implement them using another class, let's say we are using this bus class to implement this car interface, we have to override these functions and change their functionality because they are not defined inside their interface part. So this is the interface and inheritance part. So I guess this is complete, and we have discussed about everything that is needed for the basics of Kotlin. And let's do a simple overview again. So the main is the main reserved keyword, which is the entry point of the Kotlin language, and it executes this main function automatically, and we define the function using this fun keyword. So when we enter, we have two types of print statements. I'll also provide this print. We can also do this using this print, but the thing is that this println automatically adds a backslash n, if you know, a new line character at the end of the string, which makes the code or the command line much more readable. So this is the simple difference between these two. This does not add backslash n, and this adds it automatically. Then we learn how var and val works, that we can change the var keywords and the variables defined using val cannot be changed. Then we learned about how data types are assigned. We can use this colon and then provide the data type and make sure that the first word of the data type is capital. This is because Kotlin is a case sensitive language. And if we do not follow the case sensitivity, it will provide or it will give you errors. So this val, and we cannot change this val values, cannot be changed. Then how we are doing the string interpolation and also using expressions inside this. So you can do this or maybe some kind of a variable if you want to print, let's say age. So you can do this using this string interpolation. Then the data types that we have is byte, short, and long. And their range is from byte is from 0 to 175, short is from 0 to 32 767, which is roughly 16 bits. And then int is 32 bits and the long is for 64 bits. Then we have float, which is 32 bits precision. And since double is double the precision of float, it is 64 bit. Then we also have char and boolean. And char is used with single quotes, and boolean is only for storing true or false. Then we have control flow, where we have if else and when, and we can store any value that is at the last in a variable using this format, using a variable and equals to. And if the values all returned, let's say if we had if and else, and all are returning a number, then Kotlin can, before compiling or at the time of compilation, it can already know that the data type of this num needs to be a number if we are defining all numbers, and if we are returning some kind of a mixed, let's say here we are providing one, here we are providing a string, and then here we are providing a number, then the data type of this is decided during the runtime of the code. And then we have loops, and for loops we discussed how we can use this iterators I, and using this in keyword, and then using two dots we can provide a range and the start and the end point. And also how this for loop can be written down simply in simple English format in this. I'll comment this out. So this is how we write. So the iterator or whatever the name you want to give, then in for the range, then 10 down to, so that we can go from a higher value to a lower one. And the step is for the incrementations that we are doing, or maybe the decrementations that we are doing. Then the while loop for the loops, where we provide some kind of a condition, maybe some condition or some variable. This num is greater than 0, and this num is minus minus, let's say. So maybe this num was defined as maybe 10. So what will happen is this until this condition becomes false, this while loop will iterate again and again, and we are also here maintaining a variable and changing its state. Then about null, we discussed how null strings work. We need to explicitly mark it as null using this question mark. And to access it, we have save call and this always and also this double exclamation. So that and this provides us error. And try not to use this. Try not to use this. And then how functions are defined, how arrays and collections are defined, and how classes work, how we use the objects, how we create the object from a class, and then use the methods that are defined in that class using that object. Then how lambda functions are created, how we use exception handling, and this is the main thing that we need to know because in Android development we need to uh, use exception handling. We'll be using try catch blocks many times and also defining many functions and also the classes and data classes as well. And interface and classes are not used that much, but they you need to know that interface are implemented and we provide abstract functions, and then we need to override them wherever the we are implementing those interfaces in a class. We override them and change their implementation. And also this class can be inherited by another class. So I hope this session was informative for you guys and you understood something. And I guess Kotlin is easier than you were expecting. So thank you guys for the session.
किसको बोल रहा है भाई? थैंक यू गाइस।
रुक जाए पहले सेशन तो बंद करने दो उसे आदि